we're going to talk about recommendation engines for noobs. So just the very basics, going to walk through, and hopefully in the end you walk away with an intuition on how computers learn these things. $1 million for a 10% improvement. That was the tagline of the Netflix prize. It's basically a competition to find a movie recommendation algorithm launched by Netflix in 2006. It took until 2009, and when they finished, there's lots of cool war stories to share there, in how collaboration of diverse teams results in better results than they would have done individually. But we're not going to do that. We're just going to predict movie ratings. So the fundamental question we're trying to ask is, how many stars would a given user, let's call her Alice, give a certain movie? Let's call it Sharknado. Now, that question could be quite simple to answer, right? You go to IMDb, you realize that Sharknado is a terrible movie, and you conclude her rating is probably going to be terrible. But people have weird tastes, and we try to give each individual what they want. For that, we need to look at a lot of data. The data we are going to use in this example comes from a group called GroupLens. They're on a website called MovieLens, and they release a data set. The data looks a bit like this. Basically a huge chunk of blobs and numbers. What you can see is the absence of things like movie names, categories, anything. Basically, all we know is user ID 1 has rated movie ID 1 with a 4. Great. If we make it a little bit more graphical, we get something like this. It's already much better. But if we change our perspective just a little bit more and look at it in a matrix like this, we can actually start to see interesting patterns. The colors make it even more revealing. What we're now trying to figure out is what Daniel is going to like. And now just going back here, we could, for instance, say, well, actually we want to figure out Daniel's rating for The Dark Knight. We could, for instance, now look at all of the ratings for The Dark Knight and do what we did before with IMDb, and just say it's the average, it's going to be a 2. So likely going to be correct? Nope. We could then look at Daniel and Carmen and say, the ratings for movies are generally similar. Maybe we just copy the rating that Carmen gave the movie. We could also take the other perspective and look at the movies. We could see that The Dark Knight and Terminator generally got similar ratings. Daniel liked Terminator, maybe he's going to like The Dark Knight. In general, we could abstract this a little bit more and come up with labels for these movies, or features, as they would be called in the trade. So we could say Dark Knight and Terminator, action movies, Forrest Gump and Life is Beautiful. It's more romantic, I guess. We can do the same thing about users and their preferences. So we could say Alice and Bob share an affinity for more romantic movies, whereas Carmen and Daniel are much more into action. Maybe a bit nicer way to look at this than the dry numbers is on a plot. And I think it also comes with an important lesson. It's often much better to think of things on a spectrum rather than fixed buckets, because it actually reflects the reality much closer. There's also movies that might be just plain terrible and not get anything right anywhere. So now with this setup, we can start building a model. Our model is going to be an absolute oversimplification of reality, but that's what cool models do. So our predicted rating, and yep, it's going to be a little bit of math, is how much action there is in a movie times how much a user likes action, plus how much romance there is in a movie, multiplied by how much a user enjoys romantic movies. So now we assume that we just have an army of editors filling in all the blanks and telling us For each movie, it's 4 in action and a 2 in comedy. It's not really realistic, but bear with me. Might look a bit like this. And we would then need to figure out for each user what their preferences is. But that sounds like a quite doable problem, given that we know what movies they watched and how they rated them. So how are we going to go about figuring out Alice's preferences? Well, we start by just assuming random shit. Guess that's another theme. For each movie that Alice rated, we're going to do our little model, and we get a predicted rating. We can take the predicted rating and the real rating that we know from the data, and then adjust her preferences just a little bit in the right direction, so we're a little bit less wrong. The same thing we do with her preference for romantic films. Another way to look at this is a graph, where we have the error versus the preference. We're going to try to find the value in the plot, and we are going to do that by just moving down. If you remember calculus class, we can basically take the derivative of the function to move that way. If you don't, we just go downhill. In the end, we'll end up in the bottom with maybe a little bit of back and forth and wiggling. Doesn't necessarily become perfectly stable, but that's good. And it's gradient descent. It's what's powering most of modern machine learning, which is kind of crazy. So now, another way to look at this that is maybe a bit more intuitive is if we use our diagram from before. So we put Alice in a random place. We then take the rating that she gave, for instance, Forrest Gump. We do the math. We find out that we're wrong by 2.4, and we figure out, OK, that's too little. So we need to make her like Forrest Gump more. Therefore, we need to increase her preference for romance. I guess that's a much more intuitive way to go about this. And we repeat the same with the next movie rating we have. And the next movie rating, we're already much closer, but we realize that she maybe still just likes action a little bit too much, so we move it down. Now we had an army of editors tagging every single movie in the world. It's a lot of money. Can we let the users do the work? Can we just let them tell us what they want? There's another lesson in there in that it's probably a bad idea, but we could. So once we have the preferences of each user, we can play exactly the same game with the little wiggles, finding the sweet spot for each movie. And that way we can figure out what the attributes of each movie are like. So for instance, if all the romance lovers like a certain movie, it's probably going to be romantic. Same thing. At this point, you should go, wait a moment. If we can take the user's ratings or the user preferences and figure out the movie preferences, and we can take the movie preferences and figure out the user's preferences, can we do some perpetuum mobile here? Actually, turns out it kind of works. So we take the users, we use the users to refine the movies, we use the movies to refine the users ad infinitum. How do we do it? Well, we throw away all of the labels. There's no more romance, no more action, just numbers. There's feature 1, 2, 3, 4. We're going to fill them all with completely random values, and then we do the same game as before. For each rating, we calculate the error, we take the error, and then for each of the features that are now just plain silly numbers, we adjust them a little bit to make the error become smaller. Repeat ad nauseum. What will happen is that our users start in completely chaotic places, same thing with the movies, and we move them around. And that way the computer actually figures out the natural order of these things. Now, all the blah, blah is good. I kind of hope you want to see proof that this actually works. Oops. Doesn't want to go full screen for some reason. You mean like someone that doesn't know shortcuts? That'd be embarrassing, then everyone would know. So again, the same picture. We start with all of the movies in a random place. We now play this game of moving them just step by step by step, a little bit around. It's going to take quite a few iterations of this, so we'll just let it run. And this is what I find so beautiful. It's order emerging from chaos. The computer actually learns which movies go together and which might be shit from just looking at the data. So for instance, people seem to really hate The Last Jedi, whereas Rogue One seems to be held pretty close to the classic movies. Hope this is somewhat readable up there. We can also look at how good our guesses are. We see that they're steadily improving with time. Once we have this one figured out, where these movies are in relation to another in a space, we can of course also start doing recommendations of which movies are likely going to be popular and similar. So if we go over to similar movies, we can see that it now actually figured out from all of the thousands of movies that it has, that the Star Wars movies are similar, and somehow Raiders of the Lost Ark, which is another Lucasfilm movie, also goes into the same pack. You can also see the whole adjusting game is still continuing. Can try the same thing for another movie. Say we pick Terminator. And then you see the other interesting bit. Apollo 13 has something to do with Terminator. I don't know why. I guess it's maybe space fans. Now let's have just a little bit more fun with the features while we have time. So we can take Star Wars. We can add the Lord of the Rings. Now it actually figures out that the Lord of the Rings fans have a big overlap with fans of the old Star Wars movies. We can go a step further and add Harry Potter. And it actually realizes that the overlap of episode 1 and 2 and the prequels overlap a whole lot of fans of Harry Potter. I don't know how it comes to this conclusion, but it did. So this beauty from chaos is basically what I wanted to share with you, and that how little iterations can result in amazing big results if you just keep doing them for long enough. Since it's the beginning of the day, I thought it would be a good idea to share some recommendations for future talks with you, given that you're likely into the whole machine learning topic. Tim Nonner, which is I think somewhere in the room, there, will talk about the shape of 20 minutes, where he has done something, I assume, vaguely similar on 20 minutes and its data set, and figure out how things play together there. It's going to be really interesting because it's going to be the real world rather than this play data set. Marcel Blattner will also have a talk on machine learning. I assume it's going to be pretty deep from the title, but in essence, it's going to talk about why these two lines don't quite match up, and the training and the validation are not always the same. In the end, we'll have Yannick Sutter talking about how to do 4x strategy with recommendation engines. It's actually kind of what I wanted to give you in the beginning, but now left out. It's why this is important, why we as TAM Media are in such a special place with so much data, and all of these preferences we know from users from all over our portals, and how we can bring them together to achieve something much greater. Thanks a lot.